Today I want to talk about logarithms. Now this is the content that we covered in today's lesson, which is the 10th of November 2020. So if you were part of that lesson, it'd be great to just watch and recap, but we're just going to go through the first section, so introducing what a logarithm is. So, in mathematics, every single function that we have has some sort of inverse. So if I had a value and I times it by 4, let's say, what would be the inverse of multiplying by 4? So, in this scenario, timesing by 3, my inverse would be dividing by 3. Adding 3, my inverse would be subtracting 3. If I square a value, my inverse would be the square root of it, so the square root of what it is. And now this is where we come to a tricky scenario. We've got 2 to the power of x. Now, ideally, what we want to do is find x. So some people were suggesting that we could take the x root of that value, whatever it is, and that would tell us. However, that would only tell us what the 2 would be. So we need some way of actually working out x. And the way we do this is we think about this thing called a logarithm. So 2 to the x, I would rewrite as log of base 2, and then whatever my answer was, that would equal x. And the easiest way to think about this is to actually think of a scenario. So what I'm going to do is I'm going to write down just an index fact that we know, 2 to the power 5 equals 32. And I would like us to start to think about this in a different way. So rather than thinking 2 times 2 times 2 times 2 times 2 equals 32, I want us to think about this in terms of each of its components. So this 2 here is what we're actually doing. So when we're doubling, we're multiplying by 2, we're actually increasing our value. I want us to think about this as a growth rate. So this is what's happening at each stage, and the 5 is how many times we're doing it. So I want us to think about it in time. So if I had, let's say, this doubling machine, and every minute that something is in this doubling machine, it doubles. What I've done in this scenario is I've put something in the doubling machine for 5 minutes, so it's doubled 5 times, and my final answer is 32 times the size. Now, what this logarithm is going to help me out with is if I know my final result, so let's say I only see the result of my doubling machine, I want to know how long has it been in there for. The way we'd write that is, well, we'd take the base of the doubling machine, so we should note that our bases are the same here. We've got a base 2 and a base 2. That's because the growth rate won't change. But this time, if it's been on the doubling machine and it's 32 times its size, we would know that it must have been in there for 5 minutes. Now, these two forms are telling us the exact same information, but it's just a nicer way of writing it. So, I want us to start thinking about some of the things that I write down as this doubling machine. So, 2 to the power of 0 would mean that we've put something in the doubling machine for 0 minutes, so therefore my result would be the same size. If I think about 2 to the power of negative 1, I've actually put something in the doubling machine and gone back in time, so therefore instead of doubling, it's halved. 1 halved is a half. What would this look like in terms of logs? Well, this would all be in base 2, except for if we think about it, this is saying that you've put something in the doubling machine and your final result is the same as what it was. It's not changed, it's 1 times as big, so therefore it's not been in at all. And this is saying that your final result is half the size of what it was, so therefore it's been in for negative 1 minute. So what I'd like us to think about is how we could match up these equations. So the first thing I'd like you to do is pause the video now and find out the value of x for each of these scenarios. And when you've done that, you should get x equals 2, 4, 6, 8, and then 3 cubed is 27, 3 to the power 4, and 3 to the power 5. This is 4 cubed is 64, 4 to the power of 4, and this is 5 to the power of 4. Now, this is something that we should have worked out. So from here, I want us to start thinking about how could I get my final answer by looking at our logarithms. So, 2 to the x equals 4. That means I'm in a doubling machine, and my final answer is 4 times as big. So, if we look here, log of base 2 of 4 would be in a doubling machine, and my final answer is 4 times as big. If we work that out on our calculator, we should again get our value of x, which is 2. So I'd like you to pause the video and try to see, after you've written these, which of these logs would go with it. So pause the video. And what you should get is that log of base 2 of 16, the next one will be 64, and then it'll be log of base 2 of 256, log of base 3 of 27, 81, log base 3, and the answer is 243, which is here, log base 4 of 256, and finally right at the top. Okay, that's your first introduction to logarithms. If you have any questions on that, please feel free to message me or email me at any time, and thank you for watching.